Following the equilibrium was established in a container with volume V centimeter cubed at 393 Kelvin and 200 kilopascal, which would increase the yield of Rm2. So how are you going to make Rm2? How are you going to make more Rm2? Well, you could increase the concentrations of M2 and R, and then by Le Chatelier's principle it would try and lower the concentrations of M2 and R by reacting it to make more Rm2. You could remove some Rm2 as it was formed by Le Chatelier's principle. It would try and make some more Rm2 because it would oppose the change. If you're removing the Rm2, lowering its concentration, then by Le Chatelier's principle it would try and oppose that and make more of it. Let's have a look. It's an endothermic reaction, so it takes in heat when you go to the right hand side. So if I increase the temperature by Le Chatelier's principle, it will try and lower the temperature and shift to the right hand side to try and lower the temperature of the surroundings. So increasing temperature would make more Rm2. You can increase pressure. That would make more Rm2 because you've got 2 moles on the left and 1 mole on the right. So increasing pressure by Le Chatelier's principle, it will try and lower the pressure by lowering the volume and shift the equilibrium to the right hand side and make more Rm2. You could increase the pressure by decreasing the volume. So decreasing the volume would increase the pressure as well and shift the equilibrium to the right hand side. So changing the pressure to 150 pascals, lowering the pressure, no, we would have to increase the pressure. Change the temperature to 293 from 393, in other words, lower the temperature. No, increasing the temperature by Le Chatelier's principle would move it to the right hand side because it would try and lower the pressure, lower the temperature by Le Chatelier's principle to oppose that change and shift to the right hand side. So increase in temperature would shift it to the right hand side, not decrease in temperature. Remove Rm2 as it is formed. Yes, the answer is C. Change the volume of the vessel to double the volume. Double the volume would be lowering the pressure because there'd be more volume. Lowering the pressure now would shift it to the left hand side. Your answer is C. Which of the following shows nitrogen its correct oxidation states in the compounds given? So in NH3, hydrogen's in oxidation state hydrogen's in its oxidation state +1, 3 1s are 3, so the 3 H's are +3, so the nitrogen's in -3. So it's either B or C. Oxygen is in -2, so there's no charge left over, so the 2 N's are +2, so each N is in +1. So again, it's either B or C. In this one, we've got 2 oxygens in -2 because it's in group 6 forms 2 minus ions, so 2 minus 2 is a -4. Hydrogen is in +1, so -4 plus 1 is +3, so the nitrogen must be in -3 because -3 plus 3 leaves no charge left over, so the nitrogen is in +3, which is answer B.